Bismillahirrahmanirrahim. Assalamualaikum students of class 8. So unit number 7, Introduction to Chemistry. We were done with the cations and the anions of atoms. So now moving on to types of bonding. Every element is connected to another element with the help of certain chemical bonds. That chemical bonds make up the chemical composition of a substance. So, how do two substances combine each other chemically? So, there are two types of bonds: ionic bond and covalent bond. Major two kinds of chemical bonding in chemistry. Ionic bonding. Ionic bonding is a type of a bond in which a complete transfer of electrons from one atom to another atom takes place and the two substances join together. For an example, two students sitting here, one giving its entire cup of tea or material to the second person, and the concept of transferring a thing from one person to another is known as ionic bonding. For an example, if first atom is of metal and the second atom is of a non-metal, so they will combine in a form that the metal atom having positively charged ion that it requires one electron for its bonding, and the non-metal having negatively charged that it has an extra electron that it can share with the metal part. So both of the atoms combine while sharing an electron and bond together. This is known as ionic bonding or an ionic compound. This diagram represents the same thing, that the electron from the outermost shell of an atom is transferred to the shell of that atom which requires an electron for its completion. So the transferring of an electron takes place. So in ionic bonding, for an example, there are forces of attraction between two atoms. You know that the positive and the negative attracts. So this is how sodium, a metal, is positively charged, and chlorine, a gas or a non-metal, is negatively charged, and there are certain forces of attraction between them. So they gain or lose electrons to become a bond or normally a compound. So this is how the phenomena takes place. Sodium and chlorine combine and form an ionic bond, and this is usually the atoms or in between the atoms of metals and non-metals. This kind of condition arises. So these are certain ionic compounds existing in the environment that have crystalline structure, then distinct molecules. They are present in crystals. For example, sodium chloride, that would be called as common table salt. Now the covalent bonds. This is a type of a bond in which two atoms share one pair of electrons, and when two or more atoms are held together, they form covalent bonds to form a molecule. It is the mutual sharing of electrons. This is how it does not transfer its complete electron but mutually shares it in a half-half manner, and both the atoms coexist with the help of the sharing of electrons. Now, this is a hydrogen atom having one proton and one electron in its outermost shell, and the one electron in the outermost shell shares this electron with another atom, and the hydrogen atom's K shell electrons are completed because it shares one electron and then it becomes stable in the environment. I would like to share an example of covalent bond with you all, that is ammonia NH3, in which nitrogen shares electrons with one hydrogen atom. Water H2O, in which oxygen shares its electron with hydrogen atom to complete the outermost shell of hydrogen, that is 2 in its K shell. So when it shares one electron, the outermost shell of hydrogen becomes complete, and so they coexist together in the environment. Similarly, hydrogen bond, hydrogen OH2 bond is also an example of a covalent compound. So, two hydrogen atoms. I want to make it clear to you all that how does it happen. If we are having two hydrogen bonds, one electron in its outermost shell. So we know that the first shell is known as the K shell, and the K shell requires two electrons to complete its first shell. So what will happen? Both hydrogen atoms will share their electrons in a way that H2 bond will form and hydrogen gas will exist in the environment by mutual sharing of two electrons, both atoms taking benefit from the electron and not completely transferring their electron to each other and completing their outermost shell, which you can see in the bottom combination of H2 atoms. Similarly, in the case of water H2O, oxygen having two electrons in its K shell and it needs 8 electrons in its L shell, whereas it is having 6. So what will happen? Hydrogen atoms will share its one electron with the second shell of oxygen. So hydrogen shell will be completed by sharing two electrons, and oxygen L shell will be completed by having 8 electrons. So this is how it becomes stable and chemically combined with each other and exist in the environment, the water molecule. It may sound difficult to you all because it's the first step, but when we will come across it again and again, it will be easier for you all, so don't take it on your nerves. So there are certain other bondings other than covalent and ionic bonding. Those are the attractive forces between between the molecules. Those we call as hydrogen bonding, coordinate covalent bonds, and weak bondings that take place in the environment. So the attractive forces between molecules of water, hydrogen bonding, we call them hydrogen bonding. Here you can see those are the weak bondings which combine the molecules that exist in the environment. And for example sugar, if we add sugar in water, so sugar is a polar substance that it develops poles, positively charged pole, negatively charged pole, and then it mixes with water and hydrogen bonding starts, and then we get a solution of sugar and water, sweet water. So there are certain other bondings that exist in environment as well. The periodic table, we are gone with the periodic table. We are gone with the orange part, the alkali metals, the yellow part, transition elements, the pink part, halogens, the brown part, noble gases, and the lanthanides in the actinide series, the green and dull pink in the bottom. So, the first thing that arises is how to read a box, every element, how to read it. Moving on with the lightest element in the entire product table, that is hydrogen. The name is mentioned at the bottom, its abbreviation symbol H is mentioned in the box. The upper part represents the atomic number, the number of protons. The bottom one is the atomic mass, that is the number of protons and neutrons in the atom. So this is how we read every element and its properties in the periodic table. So the horizontal lines are known as the groups, whereas the vertical lines are known as the column. There is number line written on top of a periodic table. You can see 1, 2, 3, 4, 5, 6, 7, 8. And if we move on to, for an example, the second number line, and that is the orange part, that is the alkaline earth metals. So this orange line is known as the column. Whereas, for example, moving on to the horizontal lines on the left, it is written 1, 2, 3, 4, 5, 6, 7. So, moving from left to right in a periodic table, that is a group. This is how we study a periodic table. As we discussed it earlier, how do we study every element? The C is the symbol, the 6 is the atomic number, that is the number of protons. The base is the atomic mass, that is the round off figure of all the isotopes, whereas carbon is its name. This is how we study every element in a periodic table. Now, similarly, as we are done with the periodic table, the modern periodic table, there are valencies allotted to every element. Those group of valencies helps us to develop a chemical formula of the entire compounds and the substances. So if you can see in the picture, the the column number 1, that is the alkaline metals, starting from hydrogen, lithium, sodium, potassium, rubidium, the red highlighted ones. Here you can see the red ones: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. The entire column represents which valency? 1. So the alkaline earth metals, yellow part, this column B, magnesium, beryllium, magnesium, calcium, selenium, barium, radium. This entire column represents the second valency. Here you can see in this diagram which I am comparing the periodic table with. Similarly, the third column is yellow, boron, aluminium, until the bottom. Take care. So their valency is mentioned on the top of periodic table. Here you can see 1 on top. The second column you can see 2. The third column you can see on top 3. The fourth 4A on top of carbon, 5A on top of nitrogen, 6A on top of oxygen, and 7A on top of fluorine. So the valencies are also mentioned on the periodic table, and with the help of these valencies we can develop a chemical formula of any compound having metal, non-metal, whatever. So isotopes, we have discussed it earlier. The bottom number represents its mass, whereas the upper section 35 of chlorine and 37 of chlorine represents its number change in its number of neutrons. So the change in number of neutrons of an element shows that it can exist in other unstable forms in the environment as well. So these are the isotopes of there are two isotopes of chlorine. It is the same element but have different number of neutrons in it, and its relative atomic mass is determined. Relative means by adding and getting a percentage of both, that how much this stable form and this unstable form exist in the environment. We find out its percentage, then we add the result to find out the atomic mass of this element, that is 35.5 grams per mole. So these are the isotopes. They have same properties as well, not much difference. So the valency which we have studied, it is the combining capacity of an atom. So the valency tells us how many electrons does an atom need to lose or gain or to share to form a compound. For an example, sodium belonging from this line, the red part, you can see Na, that is the symbol of sodium, having a valency of 1. So the sodium 1 needs 1 electron to lose, whereas chlorine valency 1, existing in the same chlorine, having the same phenomena. Here you can see in the sixth column F, and under F it is Cl, that is chlorine, having a minus charge on it. It needs only, it has the valency that it can lose only 1 electron. Chlorine can lose only 1 electron to become stable. So this is how they react with each other and sodium chloride is formed. I can explain it to you better when I will go for and explaining you how to write a formula of each element, and I will share certain videos in my upcoming lectures and make it clear how we can go for its how can we can go for deriving a formula out of these elements, and how can we use the valencies, and how can we use their atomic mass and atomic number and develop a chemical formula which is mentioned in your notes as well. So you have to memorize and understand these in depth and detail for a better understanding. Do your homework, which is over revising all this which we have studied today, and in our next lectures I will share the concept of how to write a formula. Take care and thank you.